So the STIG Rocket, how did that idea come about?
Well, it was the objective was to be able to get experience doing space flight and getting more experience in the various aspects of actually flying things in space that we hadn't. Armadillo had a long history of doing low altitude, vertical takeoff, vertical landing stuff, really getting the controls and all of that stuff working, the engines, doing a lot of engine tests, built rocket racers, which, you know, they're airplanes, so they work in the atmosphere. But as far as flights, we were limited to doing a few thousand feet at our home location because of the way the airspace worked out. But we wanted to have experience in electronics in space and the mechanical controls in space and that kind of thing. And, you know, there are issues in working in vacuum. There's also trying to figure out how to make the whole recovery system work so that it can come back down and we can reuse it. So it started out as, it was originally a 12-inch diameter rocket, and went from there. Actually started to work on that and then decided that it wasn't quite big enough, so it became a 15.25-inch diameter rocket, which was the first STIG that was built. And then we refined the process a bit more beyond that and increased the tank capabilities by about 1.5 times without making it heavier, which was STIG A. And so we flew that twice and managed to make it to 42 and 95 kilometers, which is you know, space is arbitrarily defined as 100 kilometers, so that's real close to it. And then after that, we're building one slightly larger to 20 inches in diameter, which is by the area of roughly the same height, which is, depending on what you're measuring, is 20 or 30 feet tall. And so that one will be able to easily make 100 kilometers, 120 kilometers with a reasonable sized payload. So we're working, that's in progress right now, and we have payloads lined up for that already for doing a flight this summer. And we're hoping to do that real soon now.
But you haven't flown the STIG B yet?
We haven't flown STIG B yet. It's still in pieces in the shop. It's, you know, we're fairly quick at turning around. The last STIG A flight was in late January, and Armadillo has a long history of usually turning out about 2 vehicles a year. So if we fly it within 6 months, that'll be pretty good standard progress for what we do.
Now, the parachutes that you guys used on the STIG A seem to have failed, or was it designed to do that?
No, there were a couple of problems. On one test, we ended up having guidance problems on the way up. It just didn't quite work out. The parachute on that time worked out pretty well. It was a bit overloaded just because the rocket still had a lot of propellant in it. The first flight of STIG A, yeah, it didn't work quite perfectly, but it did come down. It came down under parachute. Some of the control lines ended up breaking. The staging is generally first after, on the way down, after you've gone past apogee, after you've gotten the good microgravity, then pop the nose off, put out a balloon, which is a balloon parachute, which is good for supersonic velocities because it's falling supersonic when it hits the atmosphere. And so it's a air-inflated structure, but it's very stable in the wake of the rocket, and it's very stable at supersonic flow, which standard parachutes aren't. And so the objective of that is to slow it down to well subsonic, and then once it gets down to a reasonable altitude of, between 20 and 40,000 feet, then open up a main parachute, which is actually guided, and then it can guide itself back to the launch site so that we can, so that it comes back to where it launched from, which is, a key to being able to reuse it quickly, is being able to just, repack the parachute, put it back on the stand, fill it back up with propellants, and fly it again, kind of thing. And so the first flight of that, the balloon shredded because it wasn't staying inflated. It's ram air inflated, and the inflation on it didn't quite work correctly. So it shredded, and the main came out at a higher falling speed than it was meant to. And so it tore some lines. On the second flight, there was some cord tangling, and there was a part of the structure that held the balloon to the rocket wasn't quite as strong as it needed to be, so it ended up getting a shock loading and tearing that off. And then the main came out at the altitude the main was supposed to come out, but at that point the rocket was falling at about half the speed of sound, and it had no chance at all. So it just departed the rocket, and the rocket crashed. But both of them were lessons. It was disappointing to see it crash the second time because that rocket was, it would have still been reusable, but that's the way it goes sometimes. So.